Hi, in this video we are going to talk about time complexities of different operations on vectors. We'll also talk about some final remarks on vectors like how do we pass them to functions, how do we traverse them in efficient ways. Let us talk about some basic functions. We'll talk about more functions later. And I think you can guess what will be the time complexity of these operations. You can think for a moment and can guess it. It's big O of 1. All these functions are clearly constant time operations. Front function has to return only reference to the first element. Back function has to return reference to the last element. Empty function simply has to check whether the size is 0 or not. Begin function has to return iterator to the first element. End function has to return iterator to the last element. Similarly, R begin, CR begin, C begin. Please remember, CR begin and C begin are constant versions of R begin and begin respectively. They return constant iterators. End, R end, CR end and C end, these are also constant time operations. Size is also big O of 1 operation because size is a member of the vector. When you remove an element, you update the size. When you delete an element, when you add an element, you update the size. So size is maintained in all the other functions. So it's a constant time operation to know the size of a vector. Let us talk about remaining two functions in this list. Pushback we have already talked about. In worst case, there might be an operation which is big O of n, but on average, it works in big O of 1 time. Popback function removes the last element. So the standard says that, the C++ standard says that the popback function has to remove the last element and has to update the size. It does not say anything about, it has to shrink the vector. So it can be considered as big O of 1 in all the cases. However, some implementations might, implement it to shrink the vector. Even then, it is big O of 1 on average, like pushback. One more thing about popback function that I just discussed. Please remember your vector can be a vector of user-defined data types. So if your user-defined data type takes a lot more time to be destructed because popback has to destruct the item and has to remove the item, then it might be taking more time. Here I am talking only in terms of number of elements in the vector and considering the primitive types. Okay, let's now talk about the remaining functions. Let's talk about insert, erase and resize. Insert function inserts an element at an arbitrary position, right? It also does multiple inserts. So if you are given an array, please remember vector internally uses an array. What is the time complexity of inserting an element at random positions? It's big O of n. So insert is big O of n. Because when you insert elements, you have to maintain the contiguity, right? Elements have to be contiguous. So you'll have to move the remaining elements. That's what makes it big O of n. Erase, again like insert, you are removing elements from random positions. So you will have to move the elements to make sure that they are contiguous locations. So it will also take big O of n time. Resize. As we discussed in the resize, we might have to add new elements, we might have to delete elements. So again, in resize, you might have to copy the old elements in the newly sized vector, and you might have to insert the new elements and have to initialize them. So it's clearly big O of n operation. So this is also big O of n. Let us now talk about passing vectors to functions. So we have a vector here which has elements 5, 7, 8. We have a function that receives a vector as an argument. It modifies the vector. It pushes 10 and 20 to the vector. And after calling the function, we are printing the vector. Can you guess the output? The output is going to be 5, 7, 8 only. The vector is not modified by the function. What is the reason? Like any other parameter, if you do not specify the reference, vectors are passed by a value. So a new vector is created here and this local vector is modified when you do pushback 10 and 20. This vector is not changed. So if you want to change this vector and you want these changes inside this function, you want these pushback and pushback functions to modify the original vector, you must pass it by reference. So now if I have added reference, I'll get 10, 20. One more thing, passing by reference is good when you want to modify the vector. Passing by reference is also good for efficiency reasons. Your vectors might be big, and if you are even not modifying them, just printing them, and if you pass them by value, what will happen? Whole vector will be copied, right? And you might get TLE, right? Many people get TLEs because they do not use references in containers. So when you're passing large containers to the functions, it's a good idea to use references. What happens when you use references? A new copy is not created because your test cases might be of size thousands, right? One more way of programming in a good way, if your purpose of passing by reference is only efficiency, your purpose is not to modify the vector, like if you are writing, say, function print, say this function fun only prints the vector contents. It does not modify the vector. In those cases, you can add a const here just to ensure that things are not modified accidentally. This is a good programming practice. So I am passing through this function. If I'm printing this vector inside this function, and my purpose is to only print it, not to modify it inside this function, then I can have both the things. I can have efficiency, and by writing const, I can ensure that this function does not even accidentally modify the vector, so that the main function is sure that this vector is not changed by this function. One final thing about vectors, efficient traversals of vectors. Here I have written a program where I have a user-defined data type, student, and then I have a vector of student type, user-defined type. I have pushed few students just to demonstrate that this is a vector of students and it has some elements. The main part where I want to focus is this thing, traversing a vector of students. What happens in this loop? What is the problem with this loop? The problem with this loop is every time a new vector element is traversed, it is first copied to S, and then you get that element and then you do whatever you want to do inside this for loop. So better idea to avoid this copying is to use reference here, right? So if you use a reference here, then this just creates a reference to that vector element. It does not create a copy of the student. See, if you are traversing the vector this way, using iterators, using something like this, for auto iterator equal to v.begin, and then that loop while iterator is not equal to v.end iterator plus plus. If you're traversing this way, this does not have this problem of inefficiency, because here iterator means addresses, pointers. So this is fine. But if you're traversing using this loop, and if you are not using reference, then there's a problem, because the whole student object will be copied every time. So it's a good idea to use reference here. It also gives you an advantage that you can modify the vector elements inside the for loop. Earlier you could not, right? As we discussed in the first lecture also. Now again, one more thing, not efficiency purpose, but just a good programming practice purpose. If you want to traverse the vector efficiently, and also if you want to ensure that this vector elements, vector objects are not accidentally modified, then you can use a constant reference, right? Just to ensure that you have efficient traversal of the vector, and at the same time you are not accidentally modifying anything. So if you do anything accident modification, like for f name change to something, you will get an error, right? So if you write something like this, you will get an error. But if you want to modify, then you can remove const, right? So that's the thing about efficient traversal of vectors when they are especially when they are containing large elements. In this video, we talked about time complexities of different functions, how to efficiently pass vectors to functions, and how to ensure accidental changes to the vectors inside the function if our intention is only efficiency. We also talked about same things for traversals of the vectors. So this is where we end the vector topic.